So our learning goals for this video today is I'll be able to determine whether two vectors are equal. I'll be able to calculate the midpoint of a vector or line segment, and I'll be able to understand and use parallel vectors to solve for an unknown coefficient. So when looking at the equality of two vectors, when a vector in I and J form is multiplied by a scalar, each coefficient is multiplied by the scalar. So if A is equal to xi plus yj, then Ka is going to be kxy. Oh, let's go to a different color. I plus kyj. Given two vectors, A and B, the two vectors are equal if and only if their x components are equal and their y components are equal. So let's take a look at this in an example. If A is equal to x minus 3, or xi minus 3j, and B is equal to 4i minus 5j, determine the value of x if the vector C, which is 2a minus 3b, is parallel to the y-axis. So let's first take a look at this vector C and do some substitution. So vector C could be expressed as 2 times xi minus 3j minus 3 times 4i, take 5j. So if we distribute this, we're going to get 2xi minus 6j minus 12i plus 15j. Okay, so we're trying to find this value of x if it's parallel to the y-axis. So if it is parallel to the y-axis, what does that tell us about this vector? Well, it means that its I component must be 0. So if you've got your y-axis here, and you've got a line parallel to it, there is no horizontal movement. So we know that our x components have to resolve to 0. So what are our x components? So x components are 2x minus 12i. So as C is parallel to y-axis, 2x take 12 is equal to 0, which means x is equal to 6. So we know that A is 6i minus 3j. All right. The vector representing the midpoint M of the line segment AB can be determined using the formula OM is equal to OA plus OB over 2. And where does this come from? Well, consider a Cartesian plane with a line going from O to point B and a line going from O to point A. And the line that can bring you from A to B has its midpoint here. So A to B is equal to O to B take O to A. That comes from yesterday's work. We can see that to get halfway between A to B, we're going to be finding O to M, which is equal to O to A plus half A to B. So if we then substitute in our value of A to B, we get O to A plus half O to B minus O to A. And if we distribute that half, we're going to get O to A minus half O to A, and we're going to get half O to B, which brings us to that top equation that we've solved there. So that's how that formula is derived. But this is the formula. Oh, sorry. This is the formula that we're concerned with. So using that, determine the vector representing the midpoint of the line segment AB if A equals 1, 2 and B equals 4, 3. So O to M is equal to O to A plus O to B on 2, which in our case is going to be I plus 2J plus 4I plus 3J all over 2. And that is going to give us 5 halves I plus 5 halves J. Okay, example 13. Given the vectors A equals 2I minus 4J, B equals 3I minus 8J, and C equals I plus 4J, determine the values of the scalar M and N if C is the sum of MA and NB. So what we're doing here is equating our components. So we know that C is equal to I plus 4J. MA is going to equal, remember we just distribute the scalar to both components, so that's 2mi minus 4mj. And then we have NB is equal to 3ni minus 8nj. So what are we doing with these? We're summing the two components and then equating them to the values of C. So MA plus NB is going to give us an X component of 2M plus 3ni and a J component of negative 4M minus 8nj. Well, what do we know? We know that this is equal to C. Therefore, 1 equals 2M plus 3n, and 4 equals negative 4m take 8n. So now we can just apply simultaneous equations to find that so if we multiply the first equation by 2, so 1 times 2, we're going to get that 2 equals 4m plus 6n. Then we can, that gives us our equation 3. If we add equation 3 to equation 2, we're going to get that 6 equals negative 2n. Therefore, n equals negative 3. And therefore, m has to equal 5. So those are our two values for the pronumerals that satisfy the equation C equals MA plus NB. Okay, parallel vectors. Two vectors, A and B, are parallel if A equals KB. So if one is a scalar multiple of another, then they're going to be parallel. Conversely, if one vector is a scalar multiple of the other, then A is parallel to B. So that property works both ways. Example 14. Given the vectors, calculate the value of x in each case if the length of the vector r is 7 and the vector r is parallel to the vector s. So for part A, the length of the vector r is 7, so we know that 7 equals the square root of x squared plus 3 squared, which means that 49 equals x squared plus 3 squared. Let's call that 9. So x squared equals 40 which means x equals positive or negative square root 40, and that can be simplified to positive and negative to square root 10. So the reason why this solution can be negative is because at this point we're just looking for a coefficient of I. So coefficients of I can be positive, they can be negative. So consider this as two lines that have the exact same magnitude, which is a magnitude of 7, but one is coming out to the right and one is coming out to the left. So they both have the same length, but whether x is positive or negative just changes the direction. Okay, part B. The vector r is parallel to the vector s. So that means r is equal to k times s, which means r is equal to 5ki minus 6kj. So if we equate our coefficients, we get that x equals 5k and that 3 equals negative 6k. So we can use this second equation to solve for k. We know that k has to equal negative a half, which means x would equal negative 5 halves. All right, and that's all of the content for this lesson. Thank you very much.